for coming in today.
Oh, it's my pleasure to be here.
So, we're talking about speeds and velocities and their relationship with light and relativity. Can you explain this to us?
Well, starting with a Galilean example, imagine a fly moving on a ship near the shore. Imagine the fly is moving 10 meters per second on the ship, and the ship is moving 20 meters per second in the water. Now, someone on the shore would then look at the fly, and from the shore's point of view, it appears as if the fly is moving 30 meters per second. And, this is very common. It's not very surprising. This is what we see in everyday life and in our experience. However, that is not quite the case. According to special relativity, the fly is not moving 30 meters per second, but is in fact moving 29.9, followed by 13 more nines, 325. So that is an extremely small difference between what we would consider the Galilean addition of velocities and also the special theory of relativity and how that affects the addition of velocities. And that's because it's a very low speed example. If you ramp up those speeds, you find that the difference is quite significant. And in fact, you find that speeds themselves are limited by the speed of light, and it becomes impossible, according to our current understanding, to go faster than the speed of light, because according to the special theory of relativity, the formula prevents it. So the speed of light becomes almost like a universal speed limit.
And you do not like this idea?
Well, the thing that I find curious about the use of the speed of light as a speed limit is, let me put it this way. If you can close your eyes and imagine you're in a void, a dark expanse, floating, as if you were floating in space or in water, but rather space because there's nothing else in there. There's no frame of reference. You're floating, and you're moving, but you're moving in such a way, rather, that there's no acceleration. It's a constant speed. Now, if you're moving at this constant speed, there would be no way of knowing how fast you are going because there is no frame of reference. There's nothing to compare yourself to. So you could literally be going very close or near the speed of light. Now, what I find that's interesting about this example is that is kind of the way we find ourselves in, being that we don't know what or if there is some central point to compare ourselves to. We are only comparing ourselves with other reference objects, which are all also moving. So the fact that we can consider this idea of the speed of light being a limiting factor, it seems to ignore the fact that it's completely reliant on the observer. And that's something that I find very interesting.
Now, why can't we exceed the speed of light?
Well, there's a couple curious things that happen as you approach the speed of light. And some of these things prevent an object or an observer or anything from going faster than light. And one of those things is that as you approach the speed of light, your relativistic mass increases, and as it approaches the speed of light, which is often called c, the relativistic mass reaches infinity, and therefore it would take an infinite amount of energy to move it. Another way of looking at it would be that the relativistic momentum when it approaches the speed of light would reach so high that it would take an equal amount of relativistic energy. And so it would take an infinite amount of time and an infinite amount of work to accelerate an object past the speed of light, or even just to it.
How do you suggest we overcome this barrier?
So I propose a shift in perspective. rather than looking at the speed of light as a limiting factor for the entire universe, I propose that the speed of light is an extremely real limiting factor, but it's limiting the observer. The reason why I say this is because it seems kind of obvious to me that given our current understanding of the universe and that how everything must be compared with everything else, that it would only make sense that light would then be compared to itself. So I'm not trying to explain away how, you can move faster than the speed of light for one observer. I disagree with that. I believe that everyone and every observer sees and understands the world in a continuum between negative c and c, or the speed of light in any direction. So the speed of light is still a limiting factor. However, it's limiting the observer and not the actual universe. So my hypothesis is that for any given observer, anything faster than the speed of light is out of their frame of reference. It almost ceases to exist. However, that's not the case for a different observer. So if you have observer A and observer B, and observer A is quote-unquote stationary, whatever that means, and person B is moving half the speed of light to person A, that person B can then experience things on his own continuum between negative c and c, which would also include things that would be the equivalent of 1.5 c using the Galilean term. But I do think that would still be applicable to the rules of relativity, and it would be a different number than just the straight combining of the speeds. However, I do think that given multiple observers and multiple viewpoints, that we have to at least consider the notion that it is our limiting factor and not the universe's limiting factor, that we can only observe things up to the speed of light rather than them not existing, that we just don't know.
Well, this is very interesting, but unfortunately we're out of time. Thanks again for coming to speak with us.
Thank you for having me.